Hello everyone! In this video, we're going to discuss about three of the classical modes of operation for the block ciphers, namely CFB, OFB, and CTR. We're going to start with CFB, which stands for Cipher Feedback Mode. In this mode of operation, the encryption function is applied over a randomly generated initialization vector IV, and then the output is XORed with the plaintext to produce the ciphertext. Later, this ciphertext is taken as the next IV to encrypt the following block of plaintext. And we continue this way for every plaintext block. The decryption process for this mode of operation is exactly the same as for the encryption process, which allows a very efficient hardware implementation. Some other advantages for the CFB mode are: equal messages using the same key will be encrypted to different ciphertexts. This requires a randomly generated IV. The decryption process can be parallelized. Errors within a single block will spread only to the following one. On the other hand, disadvantages are: blocks cannot be decrypted individually after encryption. Encryption speed is quite low. Encryption is inherently sequential, i.e., parallelization is not possible. The next mode of operation is OFB, Output Feedback Mode. It's quite similar to CFB, except that each block of ciphertext is generated by XORing the plaintext with the output of the encryption function instead of the preceding ciphertext. As for the CFB mode, we need a randomly generated IV, which is encrypted and then XORed with the plaintext in order to get the corresponding ciphertext. The most important advantages for this mode of operation are: equal messages using the same key will be encrypted to different ciphertexts. This requires a randomly generated IV. It only requires one function for both encryption and decryption. Errors within a block will only affect that very same block. It combines the advantages of the block and string ciphers. Hardware implementation is very efficient. While disadvantages are: randomness of IV is mandatory when using the same key more than once. It's not possible to parallelize either encryption or decryption. Blocks cannot be decrypted individually after encryption. Finally, we have the counter mode of operation. Like OFB, it turns a block cipher into a string cipher. It generates the next key string block by encrypting successive values of a counter. The counter can be any function which produces a sequence which is guaranteed not to repeat for a long time. The process to encrypt a block of plaintext is: load the initial counter value IV into the encryption function, cipher it, and XOR the output to the plaintext in order to get the corresponding ciphertext. Increment the counter. Take the next plaintext block and repeat steps 1 and 2 until the last plaintext block has been encrypted. Please notice that the decryption process is identical and it requires just one function as for the previous modes. The main advantages for counter mode of operation are: both encryption and decryption can be parallelized. The ciphered blocks can be accessed randomly. It's quite simple to understand and to implement. Errors will not propagate to the following blocks. It's the most secure of the three modes presented. On the other hand, disadvantages are: integrity checks are absolutely necessary for adequate security. Reusing key counter pairs is disastrous for security as well. Finally, we would like to mention as a concluding remark that CFB and OFB modes of operation have much legacy value, but relatively little value other than that. They are no longer used due to security concerns, whereas counter mode is still employed. Don't forget to like this video and to comment if you have any further questions. Thank you for watching.